So this is a review of Atom Test Part 1, and I'm going to try and write down here and have the question in front of you so that you can refer to it up here. So the first question asks about protons and neutrons in magnesium-25. Key thing to know about there is it says magnesium-25. 25 is the mass number. So the mass number means the number of protons and neutrons together. So if we consider the atom, you got the atom with a nucleus here, and you got the energy levels around the nucleus. The electrons are in the outside, and the inside contains the protons and the neutrons. So the answer to this question, the number of protons and neutrons in magnesium-25, would be 25. The number of protons in magnesium-25, though, would be different. The number of protons will be based on the periodic table. So if you go to a periodic table and you look at magnesium, it's going to pop up here in just a second. Maybe. There it comes. So you look at magnesium on the periodic table and you see that 12 right there. That tells you how many protons it has. So the protons are 12. All right, then we go back to the test. So the number of protons in magnesium-25 would be 12. The protons plus the neutrons equals the mass. So if I add those two things together, I get mass. Protons plus neutrons equals mass. So I have 12 plus whatever the neutrons is equals 25, because you see the mass was 25. So then using algebra, if you subtract 12 from both sides, you have the number of neutrons, because 12 minus 12 is 0. So the neutrons is 25 minus 12, which is 13. So you need to know this equation, that the protons plus the neutrons equals the mass. All right, so the neutrons would be 13. Now, assuming that there's no charge on the atom, in this question here, the number of electrons, that will be the same as the protons. So if there's no charge. So we said that there were 12 protons. We know that because of this periodic table here. 12 protons. So if there's 12 protons, there are also electrons if there's not a charge. Now you look at this box and it might be confusing, because right here you see there is a +2. That number tells you what the charge would be if there was a charge. So what that means is that magnesium will usually lose 2 electrons. But unless there's a charge, the protons equal the electrons. So it says here no charge, so we would expect the electrons to be 12. All right, I kind of just talked about this question. If the magnesium had a +2 charge, what changed? Well, since the electrons are on the outside of the atom here, it's the electrons that change. The things that are on the outside of the atom can come and go. That's why we've been working recently on the valence electrons, because that's what changes. So the number of electrons would change to make the charge. All right. When charge changes, mass doesn't change. And that's because we're losing and gaining electrons, and electrons are so small that they really don't have mass that's significant enough to measure. So here's a little chart that might be helpful. We have protons. Let's do it this way. Protons, neutrons, and electrons. And we say here the charge column and the mass column. Okay, so the charge for a proton is positive, and its mass is 1. The charge for a neutron is 0, and its mass is 1. The charge for an electron is negative, but its mass is so small that it doesn't affect the mass of the atom significantly. So therefore we just call it 0. So that's why that answers electron. Positive charge and lives in the nucleus, that's our proton, right here. What changes when an ion is formed? Now remember, an ion is a charged particle. So it forms by losing or gaining the outside of the atom. What's on the outside? It's electrons. So the number of electrons changes when you make an ion. Okay, isotopes of an element have different masses, but the same identity. So what's different about two different isotopes? Well, if you change protons, you change identity. So it is the neutrons that vary when you're talking about an isotope. So an example might be carbon 14 versus carbon 12. The difference between those is 2 neutrons. So carbon 14 would have a mass of 14. Carbon 12 would have a mass of 12, but they both have an atomic number of 6. They're both carbon. So what's the difference between the 12 and the 14? Well, the neutron has mass and the proton had mass. The protons are the same, so it's the neutrons that change. So that's neutron. All right, dense material has a lot of mass in a small space. So all the mass is in this little bitty space. So the nucleus is dense. So the answer is either this one or this one. But the charges in the nucleus, since you have protons and neutrons, you got a positive and a 0. Remember, these two things are in the nucleus. So you got a positive and a 0. So you're looking, the answer here would be positive and dense. So that would be the correct answer. The part of the atom that has no mass, stuff's on the outside. And in this hyphen notation, like sodium 23, 23 is the mass number. So what was the mass number? Right here is the protons and neutrons, like we said earlier. So the mass number is the protons and the neutrons. Carbon 12, carbon 13, carbon 14, they must have the same number of what to be identified as carbon. So what determines identity? It was the protons. So they've got to have the same number of protons. All right, so the red balls were protons, the gray balls were neutrons, the blue were electrons. Which one changed the identity? The red ones did. All right, and maybe I'll pull up that little activity real quick and show you here. So if I go to here, go to here. These are things, of course, we've been doing for a while, but we played the atom game some time ago. So let me go back in history. Hopefully I'll be able to find the atom game before too much time in our video goes by. Aha, here we go. All right, so let's go back and take a quick look at that question while that's loading in. So we want to know the gray balls are neutrons, the red were protons, the blue were electrons. Which one changed the identity? So what I mean by that is this. So if I do, let me move this out of the way a little bit. So if I do the mass number and that, okay, so I'm going to move in protons. You can see that the proton changed. One proton was hydrogen, 2 protons were helium, and so on. So then we have electrons. We put them in. That changes the charge. You see the charge is changing, but it doesn't change the identity. And it also doesn't change the mass. If I put neutrons in, that changes the mass, but it doesn't change the identity. All right. So back to the question. This one, which one changed the identity of the atoms? It was the red ones and the protons. Now down here, this question about the Fox Theater, when the lights are on, is the light we see released when the electrons and neon move back to their ground state or when they move away from their ground state? So when do we see the light? So this is an example. So I can take the electron here, put it out here, it gains energy. In the case of a neon light, this is helium, but I could also do the same thing with neon. In the case of a neon light, we put energy in by electricity, and the electron moves away from the nucleus, but then it falls back down. So it tries to get away, but it can't. It comes back. The electricity makes it move away, but when it comes back, it gives off energy in the form of light. So the light that we see in a neon light or in a fluorescent light of any kind for that matter is because of electron motion of this type, where the electrons move away from the nucleus and they come back down, and when they come back down they give off light. All right, I think I'm going to stop there. I think that was the last question. We'll back and check. Yep, that was the last part of part one there. Oops, the answer was moving back. They release energy when they move back is why we see the light.